Okay, class, welcome to Module 2, Lesson 10, called Sequences of Rigid Motions. So this is the last lesson before the middle of the module. This is the last lesson before your mid-module assessment. So use today to kind of review the three rigid motions. Make sure you know how to perform all three and how to recognize all three rigid motions. Today's lesson, you'll need pages 105 to 114 in your book. It's okay to rip them out so that they're easier to work with. And so for today's lesson, we're going to be talking about doing all three rigid motions. So let's review a little bit the road so far. So far in Module 2, we've learned about three rigid motions. And as a reminder, a rigid motion is a transformation. It is a change where size and shape stay the same. That's called congruency. It's a change that keeps congruency. So these are the three changes that keep size and shape constant. The first change we studied was called a translation, and translations use a rule called vectors. We also talked about reflections, and reflections are over the rule of a line of reflection. The third type of rigid motion was called a rotation, and the rule for rotations go around points using degrees. So those are the three types of rigid motions that we have studied. And so today, we're actually going to be doing transformations using all three. So there will be transformations using translations, reflections, and rotations. And the primary goal of today's practice is, can you recognize what transformations somebody else used? And can you describe the transformation that somebody else did? So can you look at two images and tell me how one of them changed? Can you look at two images and tell me how one of them made the other one? So you're going to have to spend some time describing transformations today. So you're going to look at the picture and say, is that a translation? Is that a reflection? Or is that a rotation? Or is it a combination of more than one of those? So you're going to have to recognize these three when we use them, and you're going to have to describe what happened using words. So when you describe a transformation, so you're going to use transformations you're going to use all three transformations, and you will have to describe them. So when you describe them, when you describe a transformation, there's two parts of your description. Your description has two parts. Part one, you tell me what kind of transformation it was. Was it a translation? Was it a reflection? Was it a rotation? So part one, you tell me, did the person translate, reflect, or rotate? And then you also have to do part two. You have to tell me what rule the person followed. So you say they translated with this vector. They reflected over this line. They rotated around this point. So you need to tell me both parts. You need to say translate and name a vector. You need to say reflect and name the line. Or you need to say rotate and name the point. This is about being precise. This is about being specific. So make sure you are doing both parts of the description. The kind of transformation and the rule it followed. You need to tell me the kind and the rule every time it is possible. That is about being precise. That is about being specific. You need to tell me the kind and the rule. But we're going to do some practice together right now so that you can see how I do my descriptions of transformations. So let's start on the first page of your lesson. Go to page 105, and the top of page 105 looks like that, where you can see we have two triangles. We have triangle ABC, and I can just look, and we have triangle A prime, B prime, C prime. Two triangles. Let's read the description of the problem. In the following picture, triangle ABC, which is this one on top, can be traced onto a transparency and mapped onto triangle A prime, B prime, C prime. That means traced and mapped means it can move. It can be changed. It can be transformed. So triangle ABC is transformed to turn into triangle ABC prime. Which basic rigid motion, so which rigid motion or sequence, that means more than one, would map one triangle onto the other? So the question is asking, let me summarize the question for you. How does triangle ABC become triangle A prime, B prime, C prime? So think about your three rigid motions. Look at your note page if you have to. I'll even help you out with this one. There is just one rigid motion that will map this, that will transform, that will make ABC become ABC prime. If you look, it does not look like it slides. It does not look like it spins. It looks like it flips. So I'm going to actually just test this with my transparency. I'm going to trace triangle ABC, and then if I try to slide, it doesn't line up. If I try to spin, it doesn't line up. So the only one that's left over is if I flip my transparency over, and that lines up. So this was a flip. But we don't say flip, we say reflection. So you need so this is a reflection. But remember, that is only part of the description. You need to tell me the other part, because it says reflection over a line. So we did what kind of transformation? It's a reflect over what line? Well, what line are we flipping over? Well, if you look, we're flipping over this line right here. That is the line that gets flipped over. So we need to name that line. So we say it's a reflection over line BC, because those are the points that make the line. Reflection over line BC. Reflection over line BC. That's the answer. How does it move? We have the type of transformation, and we have the rule. And I did not just say reflect over line, I said the name of the line. So I am very specific, so everybody understands exactly what happened. Let's look at number 2. And you can work ahead. If you think you know the answer for number 2, go for it. Number 2 says, in the following picture, triangle ABC can be traced onto a transparency and mapped onto triangle A prime, B prime, C prime. What basic rigid motion or sequence of would map one triangle onto the other? So that is the exact same question as before. We just have a different type of transformation. It is still asking, to summarize the question, how does triangle ABC become triangle A prime, B prime, C prime? Well, if you look at this one, here's my triangle, here's my traced triangle. I'm going to label my vertices A, B, C. It's not a slide because a slide does not make it line up. It's not a flip because if I flip it over, it does not line up. But what happens if I spin it a little bit? If I just spin it like that, you can see there it goes, it lines up. So it is a spin. Only we don't say spin, we say rotation. So what rigid motion did it? It was a rotation. But that is only half of the answer. Because if you look at our notes, I told you what kind, it's a rotation. You also need to tell me what rule. And so for rotations, we need to say around what point? Around what point? Well, for this one, look at this rotation. What point stays in the same spot? A moves from there, goes here. C moves, but B does not move. So because B does not move, we say it's a rotation around point B, because B is the center of the rotation. B is the spot that does not move, so that is the rule. That is the point. Now, some of you might be saying, Mr. Baylor, don't we have to tell degrees? How many degrees did it rotate? Not today. Do not worry about telling me how many degrees it rotated today. We'll worry about degrees another day. Today, you just need to say it's a rotation, and it goes around the point, and be specific and tell me the name of the point, point B. That is the answer for number 2. Take a minute, pause the video, check your answers for 1 and 2. Make sure you understand how I did number 1 and 2 before we are ready to move on to page 106. Okay, hopefully you understood page 105. You know how to do one-step transformations. Starting on page 106, we're going to start doing combinations or sequences of rigid motions. Let's look at number 3 on page 106. So let's read the instructions again. In the following picture, triangle ABC can be traced onto a transparency and mapped on a triangle ABC prime. Which basic rigid motion or sequence of would map one triangle onto the other? So the question is the same. How does triangle ABC become triangle A prime, B prime, C prime? How does one move on to the other? So I'm going to tell you right now, it is not just one rigid motion. This is going to be a sequence, more than one. Let's get the transparency and trace it so that you can see what I'm talking about. Because I'm going to trace the original triangle ABC. And now a slide won't do it, does not match. A flip won't do it, does not match. And a spin won't do it, does not match. So it has to be some kind of combination. Now, looking at this, you can see some clues about what to do. So for example, if you look at triangle ABC, look at the original, A is pointing to the top of the page. If you look at triangle ABC prime, A is now pointing to the bottom of the page, which means A at the top, A at the bottom, there was a flip. There was a flip, which means we will have to reflect because A is up here, but it does not stay up at the top. So the first thing you can say is, Mr. Baylor, it looks like you have to flip. So if we flip, then it looks like that. But we're still not done because it's not lined up. But then you could say, well, Mr. Baylor, what if we spin a little bit? What if we start to spin it? And then you see, wait, okay, that did it. So we flipped over and then we spun around. So there were two transformations, two rigid motions, a flip and a spin. So let's use it with mathematical language and our rules. So step one was a flip, but we're going to say reflect. And saying reflect is not good enough, remember. Just like on the last page, we have to say what line are we reflecting over? What line do we flip over? Well, if we flip over here, we are flipping over again this line right here. We reflect over BC. We reflect over BC. That is what we flip over, because BC stays in the same spot. BC stays in the same spot. So that is what we reflect over. Step two, because after we reflect, the images still don't line up. So for step two, we said we needed a spin. Well, we use the word rotate. So we rotate. But what do we rotate around? Remember, you need to tell me a point that we rotate around. Well, here's our flip. When we rotate, what point stays in the same spot? If you look, B stays in the same spot. So we flip over BC and we rotate where B is the center. So flip over BC and then rotate around point B. Just like that. And if we reflect over BC and we rotate around B, that is how the triangles match. So that is the answer. So this was a two-step transformation. Two rigid motions. You needed a reflection and a rotation. And remember, you also wrote the rules that you follow. Let's look at number 4. Number 4, in the following picture, we have two pairs of triangles. In each pair, triangle ABC can be traced on a transparency and mapped on a triangle ABC prime. Which basic rigid motion or sequence of would map one triangle onto the other? So this is the same thing, we just have two parts. How does triangle I'm going to try that again. I messed up. How does triangle ABC become triangle ABC prime? How do we make it happen? Well, let's do scenario 1 first. So we'll do scenario 1 first. Don't look at scenario 2 yet. Just do one piece at a time. So here's triangle ABC. How does that become triangle ABC prime? Well, look at them both and think about your rigid motions. Is it a translation? Is it a reflection? Is it a rotation? Is it a slide? Is it a flip? Or is it a spin? Now I can see from this, it's probably going to be a combination. It's probably going to be a combination of more than one. So what I'm thinking we have to do is first, I'll get my transparency so you can see what I'm doing. Let me trace the original and let me play around with it to try to come up with rules and type of transformation and rules. Well, I can see that A is pointing to the top of the page, and A prime is also pointing to the top. So it does not look like we flipped anything. This does not look like, if I look at both triangles, it does not look like they flipped, because A and B are still on one side and C is on the other one. it looks like what happened was I did a slide over here, a slide like that, and then I did a rotation like that. That's what it looks like I did. Looks like I can do a slide right there and a spin right there. I don't need to flip. I just do a slide and a spin. So those are my two steps. Step one is a slide, also called a translation, or so we translate for step one, and for step two, we spin or we rotate. Now, that's only half my answer. I still need to know what rule I followed. Now, this is where different people might have different answers. So, because watch what I can do. When I translate, if I connect A and A, I can do that and spin around A. Or if I start here and I slide and I look at the B's, I go B to B prime, and then I spin around B prime. Or I can connect C and C prime and slide that way, and then I spin around C prime. So if you'll notice, you have really three different choices. Now what I'm going to do for mine is I'm just going to follow the A to A prime vector. So I'm actually going to draw that vector on my diagram. So because I want to be precise and I want everybody to understand my rule, I'm going to show you the vector I used. That's my vector. Now you can also, suppose you don't like the A prime vector, you can follow that vector. Or if you don't like A or B and C is your favorite letter, you can follow this vector. All three vectors will work. It just changes where your rotation happens. If you follow my green A vector, you rotate around A. If you follow my red B vector, you rotate around B prime. If you follow the pink C vector, you rotate around C prime. So you can follow whichever vector you want. Just pick your favorite. I'm going to pick vector A. So I'm going to say translate with vector A prime. And that's how you make a vector. Remember, that's how you write a vector. So that's my vector that I'm going to follow. I'm going to follow the A prime vector. And then if I do that, I have to rotate around A prime. You can also, but if you follow a different vector, that's okay. It just changes what point you rotate around. Let's look at scenario 2 and see how that one moves. So we still have two triangles. How does ABC become ABC prime? Well, if you look, it's not really a slide. It's not really a spin and a slide. This is where you get your transparency out and you just play with it to try to make it match. I'm not even sure even if I reflect it and slide, that's still not going to line it up. So it looks like I have to use all three. Watch what I do. I'm going to reflect first. Why not? You might, by the way, it's okay if you have a different order as long as it still works. So in my opinion, I just like to reflect first. Get that out of the way. So I'm going to reflect, and then I'm going to go to connect B with B prime. I'm going to slide up like that. And then last thing I'm going to do is I'm going to rotate to make it match. Let me show you that one more time. There's the original. I know I have to reflect. I know I have to flip. So I flip it over like that. And then I slide it. And then I spin it. So I had to use all three. This is a 3-step transformation. So first step, I flipped, which it means I reflected. Step 2, I made a slide, which means I translated. And step 3, I spun it, which means I rotated. So, but that's only half my answers. I have to write the rules. So when I flip, what did I flip over? First, I flipped and B and C stayed in the same spot. So I reflect over BC. BC right here is my reflection line. That's what I flipped over. Now, what vector did I follow for my translation? Number 2. Well, remember, I connected the B's. So I followed this vector that I'm doing in red. So what vector did I follow? I translated with vector. Vector is the arrow. And I started with B, and I went to B prime. So translate with vector B prime. And then after I reflect and I translate, what did I spin around? B prime stayed in the same place. So I rotated around this point right up here, rotate around B prime. And that is the 3 steps that made the triangles match. Hopefully you got what I just did. You might be working a little bit ahead of me and you understand and you're just checking your answers. But if you're getting it, awesome. If you're not understanding it, make sure you ask some questions. Look at page 106 again. Make sure you understand how I did all the parts, and you can even check it with your own transparencies. If you have any questions, remember to reach out to me and I will help you. Okay, class, hopefully you took a minute to check your work on page 106. Maybe try a couple different ways to solve these, because there is more than one right way to do this. There's some wrong ways to do this, but there's also more than one right way. So let's practice again. Let's do another piece of practice. Page 107, number 5, practice number 5, where we have 2, I don't even know, those aren't really wedge shapes. They look like, I don't know what you would call those, but 2 funny looking shapes. Not triangles anymore, so at least we're not using the same triangle over and over. They gave us something that looked a little bit different. Number 5, let 2 figures ABC and ABC prime be given so that the length of the curved segment AC equals the length of the curved segment AC prime. Angle B equals angle B prime, and they're both 80 degrees. So I can even add that information because they told me this is 80 degrees. And AB equals AB prime, which is 5. So AB is 5 and A prime B prime is 5. With clarity and precision, which means telling me rules and tell me what type of transformation and tell me the rule, describe a sequence of rigid motions that would map figure ABC onto figure ABC prime. So again, the question is, how does ABC become ABC prime? How do we turn one into the other? So some of you might be good enough where you can just do this by looking at it, but some of you might just want to experiment and play with the transparency a little bit, which is absolutely okay. Why not? I mean, if you're going to do math, you might as well have some fun with it, and the transparencies can be fun. So let me trace the original. And one thing I'm going to do with the original is I'm going to label my points so that I don't get confused about which point is which. because it might be very easy to trade A and C by accident. So I'm going to trace and label. And now I can play around and see, okay, well, let's see here. Let's just first slide. Let's connect B and B prime. Let's just slide down to B prime. Okay, now I'm closer, but I'm still not exactly there. Maybe if I rotate like this, does that make it match? You might say, well, that looks close, Mr. Baylor, except this is the reason I labeled my points. If you look, A is the original, but it's next to C and C prime. And A prime is next to C. So that doesn't work. So if I just slide and spin, we have the wrong letters next to each other. Because A has to go with A prime, C has to go with C prime. So obviously, if I do this, what I should do is I should rotate until that lines up like that. This takes some playing with. So play around with it for a little bit. If you want to pause the video before I give away the answers, please pause the video and you can play around with your transparency to see how it works. But I'm going to slide. I'm going to spin. And then I want to get this C over here where C prime is. So I'm going to flip right there. And that is what works. Let me show you one more time. I translate. I connect my B and B prime. I rotate until AB and AB prime line up. And then I flip over AB prime. And there we are right there. That lines up. I have A on top of A prime and C on top of C prime and B on top of B prime. One more time for funsies. Slide down to connect the B and B prime. Rotate to make AB and the line AB line up with AB prime. And then flip over to make a match. That's one way to do it. You might have a different way to do it. But that's the way I like it, and I can also tell you my rules. So the first thing I did, we have step 1. We have step 2, and we will have step 3 because we used all 3 rigid motions. Step 1, remember, was a slide. So the first thing I need to do is translate because we don't say slide. After I translated, I did a spin, but we don't say spin. We say rotate. And then the last step was a flip, but we don't say flip. We say reflect. So those are my 3 steps. But remember, I need to be precise and clear and tell you my rules. So remember, when I translated for step 1, I connected the B's. So my vector is going to connect B and B prime. So that's the vector that I followed. So I translate with vector, start with B and go to B prime. That's the first step. So I follow the vector right there. And then I rotate. What am I rotating around? What point is staying in the same spot? Well, if you look, B stays in the same spot. So I rotate right here around point B. Now I'm right here after I rotate. I reflect. But reflect, remember, I need a line of reflection. So what line do I flip over? What line stays in the same place? And if I flip, you'll see that AB stayed in the same place. AB is the line that I flip over. So this right here is the line that stays when I flip. So I reflect over AB, line segment AB. So those are the 3 steps that I have. I translate and I follow that vector. I rotate around point B right there, and I reflect over this line segment right here. I am clear, I am precise, I have the kind of transformation, and I have the rule. So that's the best that I can do. Take a minute, pause, look at number 5, play around with your transparency a little bit more, see if you can find a different way to do it. And then when unpause, we'll come back and we will talk about today's independent work. Okay, class, that was page 107. That is the end of our guided practice where I do things and we talk about them and we discuss. Hopefully you got all 3 steps and you know how to write them precisely with what you do and with the rule you follow. Time for you to show me what you've learned. This is the exit ticket on page 109. Just slide that to the back of your packet because that will be the last thing you do today. Here is the homework helper where they give you another example and more explanation. So if you want to see another example and the book's explanation, you can follow this, and the homework helper should give you some guidance. On page 113, you get the problem set for today. And if you'll look, this time you're going to be doing pretty much the same thing. Let's read the directions so that I can explain them to you. Let there be a translation along vector v. So you have a translation with vector v, which is right here. Let there be a rotation around point A. So here's point A that you're going to rotate around. Negative 90-degree clockwise. Oh, so that you have to go this way. So you're going to go 90 degrees that way, clockwise. And let there be a reflection across line L. So you're going to reflect over line L, which is line L is right there. So you have a translation, a rotation, and a reflection. And let S be the figure shown below. So this S, this triangle, is the figure that I think you're going to be doing things to. Show the location of S. So how does S move after this sequence? The translation, followed by the rotation, followed by a reflection. So that's the order you're doing them in. Do the translation using vector V first. Then you do the rotation around point A. And the last thing you do is the reflection over line L. So you're going to do 3 different things, one after the other, and so that your figure will be in the exact same place that my figure will be when you check your answers online. So do the translation with this vector, rotate negative 90 degrees around point A, and then reflect over line L and see what you get. For number 2 on the problem set, would the location of the image S in the previous problem, so still talking about S up here, be the same? So would it be the same if the translation was performed last instead of first? So in other words, does the order matter? So it's asking, does order matter? So for number 1, move S with translation, rotation, reflection. And then for number 2, do the rotation first, then do the reflection second, And then last this time, do the translation. So you're going to do these transformations twice. You're just going to change the order. So for number 1, I want you to label it S prime after you move S. And for number 2, after you move S, I want you to label S prime prime. So I want to see 3 triangles on this graph. The original, and then one for number 1 and one for number 2, where the order changes. And I want you, for number 2, I want your answer to the question, does the order matter after you do them in different orders? So I want you to show me what you did and then describe if the order matters. Page 114 has another problem on graph paper. It says use this, so we're supposed to use this graph for parts A, B, and C. So here's our triangle that we're going to move up here. Here's triangle ABC that you are going to transform. Let's read the directions about what you're going to do. Part A, reflect triangle ABC. So you're going to reflect across the vertical line parallel to the y-axis that goes through point 1, 0. So parallel to y and goes through this point. So point 1, 0 is 1x, 0y, so that's the point. And has to be vertical parallel. So for part A, you are going to reflect over that line and label. Reflect and label, and that's the line you use. For part B, it says reflect again across the horizontal line parallel to the x-axis going through point 0, -1. So let's find this point. 0, -1 means 0 on x, -1 on y. So this is the point right there that they're talking about. And the line has to be horizontal, which means it's flat like this, and it's parallel to x. So if it has to be flat like this, parallel to x, and touch that point, that's your line for number 2. And then remember label. So you're going to reflect it one time over the blue line, and then reflect it again, reflect the new image over the red line. So you're going to do prime and then prime prime. And then answer the question, is there a single rigid motion that would move, that would map after number 2, after part B, back to the original? So can you, when you find your new one, is there a way to get it back with only one step? Is there one step that will move it back? So these are some problems for you to practice. Remember the problem set on page 113 and 114. I will put my answer sheet online for you so you can check your answers when you're done. And you can ask me questions if you see any differences. After you finish the problem set and check your answers with mine, you should go back to page 109 and complete the exit ticket. And the exit ticket is what you're going to take a picture of and turn in on the Google Classroom today. So there's just one problem. It says triangle ABC has been moved according to the following sequence. A translation followed by a rotation followed by a reflection. So there was a translation, a rotation, and a reflection. With precision, describe each rigid motion that would map it. So in other words, be precise and tell me exactly how they did it. So which means tell me the rules they followed. They already told you this, the types. They said a translation, a rotation, and a reflection. You just have to tell me those 3 steps with the rules that they followed. So what was step 1? What was step 2? What was step 3? Just like we did together in class today. Tell me those 3 steps. Take a picture of it, turn it in to show me what you learned today and to be more prepared for your quiz coming up this week. Thank you for following along today. If you have any questions, remember to reach out and ask, and I will gladly help. Have a good day. I'll see you for the next lesson.